Okay, so in this video, we're going to be doing synthetic division still, but we're going to be using synthetic division to find our zeros in the level 1 assignment of Delta Math. So it's the same thing as we were doing with the last assignment, but we're just adding a couple extra steps on to the end. So I'm going to write down what I'm starting with. I have x to the third minus x squared minus 22x plus 40. And it says that x minus 2 is a factor of f of x. So we would be able to evenly divide this function, the long polynomial that we started with, by x minus 2. So I'm going to divide it by x minus 2. And we're going to find out what we have left once we divide the two. So we're going to use synthetic division. So I'm going to start by finding the coefficients of my numerator. I have a 1, a -1, a -22, a positive 40. 1, -1, -22, positive 40. And we know that if we're dividing it by x minus 2, I set it equal to 0 and solve for x. So adding 2 to both sides, I get x equals positive 2. You start by bringing this first number down, so 1 starts in the bottom. Whatever in the bottom row gets multiplied by my red 2. So 2 times 1 gives me 2. Add up and down, -1 plus 2 gives me 1. 2 times 1 gives me 2. -22 plus 2 gives me -20. 2 times -20 gives me -40. And I have my remainder of 0. Since I started out with a degree of 3 and I divided it by x to the first, just a degree of 1, my answer is going to have x squared as the leading coefficient degree. My answer is going to have x squared as the first term. So I have 1x squared. I'm just going to write that down as x squared. Plus 1x. I'm just going to write that down as plus x. And then minus 20 without an x on it. And so I know when I divide these two things, I get x squared plus x minus 20. That's the same thing as saying, let's do just regular numbers for a quick example. If I did 20 divided by 5, I get 4. We know if we do 20 divided by 5 and we get 4, we can do 5 times 4 and get 20, kind of like working in the reverse order. So that's telling me that my f of x, this numerator, is going to be equal to multiplying my x squared plus x minus 20 and my x minus 2. So now I want to find the zeros of this function. And if I want to find the zeros of it, I'm going to set it equal to 0. So it doesn't need to be f of x equals anymore. Looking at what I have a quadratic in this first parentheses, and we know that we can factor a quadratic easily when a equals 1. So I'm thinking of what multiplies to -20 and what adds to a positive 1. What multiplies to a -20 and adds to positive 1, that's x plus 5, x minus 4. 5 times -4 gives me -20. 5 plus -4 gives me positive 1. And I'm going to bring this x minus 2 down. Now we have our 3 different parentheses that are set equal to 0. So we can easily set each piece equal to 0. If I have x plus 5 equals 0, if I were to subtract 5 from both sides, I get x equals -5. If I have x minus 4 equals 0, I could add 4 to both sides and I get x equals 4. If I have x minus 2 equals 0, I could add 2 to both sides and get x equals 2. So I have my answers -5. I'm going to separate them by a comma, 4, and 2. We can do another example like this one. I'm starting out with x to the third minus 6x squared minus 45x plus 50. And it says that x minus 10 is a factor of it, so I can easily evenly divide x minus 10, and I'm going to use synthetic division to do so. So my coefficients of the numerator is 1, -6, -45, and 50. So 1, -6, -45, and 50. If x minus 10 is in my denominator, I'm going to solve for x. If I were to add 10 to both sides, I get x equals 10. So 10 is the number on the left side. Bring down the first number, 1. Everything in the bottom row gets multiplied by 10. So 10 times 1 gives me 10. Add top and bottom, -6 plus 10 gives me 4. Multiply it by 10 to get 40. -45 plus 40 gives me -5. 10 times -5 gives me -50. And we have our remainder of 0 that we want. So this gives me the answer of 1x squared plus 4x minus 5. I am going to write that as the product to equal the original polynomial that I was given. So I have as my answer right now x squared plus 4x minus 5 being multiplied by what I divided by in the first place, x minus 10. And I'm trying to find the zeros of this, so I'll set it equal to 0. You have a quadratic in your first parentheses that you can factor, because a equals 1, you can do the quick trick of what is multiplying to -5 and adding to 4. X plus 5, x minus 1. You'll bring down your x minus 10, and everything's set equal to 0. So you're going to individually set each of these pieces equal to 0, which is just like flipping the sign. If x plus 5 equals 0, you know that x equals -5. If x minus 1 equals 0, we can flip the sign. X will equal +1. If x minus 10 equals 0, you can flip the sign. X will equal +10. So we get -5, not 51, -5, 1, 10. Now, the second way that you might see these examples is by, instead of saying x minus 10 is a factor of, like we had in the last example, it'll say f of 4 equals 0. And we can do the same thing, same steps and everything. This is saying that we are taking x squared minus 10x squared plus 17x plus 28. And over to the side, if f of 4 equals 0, that's implying that x minus 4 is a factor. So you just do the opposite of whatever's inside your parentheses. So we're going to be dividing this by x minus 4. And we know when we're doing synthetic division, we're going to start out with the coefficients. So 1, -10, 17, 28. And if we are dividing by x minus 4, we know that the number out to the left is going to be the opposite of -4. So it's +4, which is what we started with in the f of 4 equals 0. So now we can solve with synthetic division, bring the 1 down. Anything in the bottom row gets multiplied by 4. So 4 times 1 gives me 4. Add top and bottom, -10 plus 4 gives me -6. 4 times negative 6 gives me negative 24. 17 plus a negative 24 is going to give me negative 7. 4 times negative 7 gives me negative 28. And I have my remainder of 0. So now I have 1x squared minus 6x minus 7x. I'm going to write it as a product with what we divided by. So I have x squared minus 6x minus 7. Oop, I made a mistake. This is not minus 7x. This is just minus 7, a constant, because we're going down a degree each time. And that's being multiplied with my x minus 4. And if we were to multiply this out, we would end up with this top polynomial. We're looking for the zeros, so we're going to set it equal to 0. Looking back at my first set of parentheses, I have a quadratic that's easy to factor. What multiplies to negative 7 and adds to negative 6? X minus 7, x plus 1. Bring down the x minus 4. And you're going to set each of these parentheses equal to 0, which you can just flip the sign. Negative 7 becomes positive 7. Positive 1 becomes negative 1. Negative 4 becomes positive 4. 7, comma, negative 1, comma, 4. All right, let's do one more example like this. So for this example, I'm starting off with x to the third minus 13x squared plus 46x minus 48. And I was told that f of 8 equals 0. This notation implies that x minus 8, we're flipping the 8 to become a negative 8 with the x, is a factor. So I can divide it by x minus 8. My coefficients, 1, negative 13, 46, negative 48. On the left, if I have x minus 8, I would set it equal to 0 and add 8 to both sides to get positive 8, which is what we started with in our notation of f of 8. I'll bring my 1 down. Whatever's in the bottom row gets multiplied by 8, so 8 times 1 gives me 8. Negative 13 times 8 gives me negative 5. 8 times negative 5 gives me negative 40. 46 plus negative 40 gives me positive 6. And when 8 times 6 gives me positive 48. So my remainder of 0. So now I have, when I divided, 1x squared minus 5x plus 6. I'm going to write it as a product with my x minus 8. X squared minus 5x plus 6. X minus 8. If I'm trying to find the zeros, I'll set it equal to 0. I'm going to factor the quadratic in my first set of parentheses. So what multiplies to 6 and adds to negative 5? That would be negative 3 times negative 2. Bring down my x minus 8. And if I were to set every single parenthesis equal to 0, I can easily just flip the signs of my constants. So 3, 2, 8.